Hello everyone, we will start our solutions, acids, base and salt topic. Let's get started. So what are we going to learn in these topics? We will define solution, solute and solvent. We will talk about examples of solutions. We will define concentration and solve some examples from the regions questions. What is a solution? A solution is a homogeneous mixture. It is not a pure substance. It is a mixture, but a homogeneous mixture, which means when you look at it, you will only see one face. A solution is a homogeneous mixture of a solute dissolved in a solvent. The solubility of a solute in a given amount of solvent is dependent on temperature, pressure, chemical natures of solute and solvent. Okay, let's talk about this now. Let's say that is a sugar. Okay, our solute is sugar. Solute is the one that you are going to dissolve in solvent. And let's say that is water. You are going to mix sugar in water. So your solute is sugar, solvent is water. The solubility of solute. So you want to dissolve the sugar in water, and the solubility is, which means it's going to disappear in water, depends on amount of solvent. If you have huge amount of sugar and less amount of water, it is going to be hard to dissolve it. It depends on temperature. If you have a hot coffee or hot tea, it's gonna dissolve easier compared to cold. The pressure, for example, if you drink like soft drinks, the gas in it, the carbon dioxide gas in it, if you open it, you will hear a fuzz sound. That is, you are changing the pressure when you open the cap. And chemical natures of solvent and solvent. Chemical natures, we can say, if you mix water and oil, they are not gonna soluble. They will not solve each other, right? That is due to chemical natures. So we define solute, solution, and solvent right now. So I hope we can put a check mark here, right? I hope we can put a check mark next to this one. There we go. Now we will talk about example of solutions. Remember, solvent is the one that you are dissolving. Like water is your solvent, okay? Here you can dissolve the different states of matter in different forms. Let's say you have air. Air is an example of homogeneous mixture because you can see oxygen and nitrogen and carbon dioxide in the air. They are all homogeneously mixed. It is a solution. So nitrogen is 70%, so it is our solvent, and oxygen is dissolved in it. So solute is a gas state, solvent is a gas state. For example, club soda. Your solvent is liquid, water, and you are dissolving carbon dioxide in it. It's in the gas phase. Your solvent is, for example, solid, which is platinum. You take the platinum metal and your carbon monoxide gas attached to it, and you dissolve carbon monoxide in platinum. Like gas, you can have all sort of these examples in the nature, and you can have different state of solute and solvent. For example, you can dissolve liquid in liquid. This is alcohol. We mix water and alcohol. Both of them are solid. You can mix metals. You can melt metals. Both of them are solid. Liquid, solid. That is, in water you have sea salt, right? This is naphthalene in air. Your solvent is gas and naphthalene particles are in it. They are solid particles. Like dental amalgams, the mercury is liquid, and you are adding this to the mixing it with silver. So your solvent is solid, you are adding the liquid in it. So these are some examples of solutions you see in daily life. So when you make solutions, the boiling point will increase and freezing point will decrease. The addition of a solid to a solvent causes the boiling point of solvent to increase and the freezing point of the solvent to decrease. If you add more particles, that will have greater effect. Where do we see that? We see it in winter, right? When it is snowing outside, you see the construction trucks, they are adding salt on the water, on the icy roads. So what happens there? It decreases the freezing point. For example, water freezes at 0 Celsius, but if you add salt in it, now there will be no ice on the roads, even it is -10, -20 Celsius. Okay? How about boiling point increase? For example, if you are boiling water to make pasta, if you add the salt before boiling the water, it will take longer. So what we should do, we should first boil the water as it is, and then after it boils, you add the water. Because salt will increase the boiling point. Normally, water boils at 100 Celsius. If you add salt in it, it is going to increase 104. So you have to wait extra longer to reach that 104 Celsius. Okay, makes sense? So if you have to save time, save energy, boil the water first, then add the salt, sorry. So these are some. Now we will talk about concentration. When you make a solution, you mention the ratio of solute and solvent as the concentration of solution. It can be expressed as molarity or percent by volume, percent by mass, or part per million, ppm. You may see that in the news, like the carbon dioxide level is that much ppm, the toxicity level, the mercury level is that much ppm. So that is how we talk about concentration when we prepare solutions. I'm going to show you some examples here. For example, if you buy a painkiller, where did it go? Let me change the order. Bring it front. If you for example, buy a painkiller, look at these ingredients. Active ingredient is it say if you take this amount of milliliter, it's going to be 80 milligram. In each 0.8 milliliter, 80 milligram will be the active painkiller ingredient. Or you can change it like this. This is volume, this is mass. That is how we talk about that's how you see the concentration. Or, for example, again, we need to change order here. You buy vinegar, look at the concentration here. They are talking about percentage. It says 5% acidity, which means if you have 100 volume of vinegar, 5% is acid, which is acetic acid in vinegar. Or that is the allergy. That is the allergy shot, epinephrine. So it gives like 0.1 milligram per every milliliter. So every solution has a concentration that we need to label. If you go to lab, you will see sulfuric acid, and it is going to say like that is the ammonia in sulfuric acid, it is just 1 part per million. If you take 1 million of sulfuric acid, 1 part will be the ammonia in it. That is the sulfuric acid, we say molar, 6 molar. Or there's a normal, we can also say normal. These are all talking about ratio of solute in solvent. And I will show you how they ask these questions in the Regents test. In our reference table, we have formulas and equations. What we are going to focus is that part, concentration part. When they ask the question, they will ask part per million or molarity calculations. And all formulas are right here. Now let's focus these formulas. The concentration is, if they are asking molarity, what is the molarity of this solution? They may ask like this. You need to find moles of the solid, like if your solid is salt in water, you need to find how many mole and then divide it by liter. If you forgot how to calculate moles, mole calculation formula is also in the table. How to calculate mole. Given mass divided by gram formula mass. If it is part per million, you will take the mass ratio of solid and solution, and since it is million, you multiply it by 1 million. Let's do some examples here. First example, that is the last year Regents chemistry question. The molarity of 2 liters of an aqueous solution that contains 0.5 mole of potassium iodide. What is the molarity? They are asking molarity, so we are going to use this formula. Molarity is moles over liter. Do we know the mole? Do we know the mole number? Yes, mole number is 0.5 mole. Do we know the liter? Yes, it is 2 liter. You will divide 0.5 mole divided by 2 liter, which is 0.25 molar. So the answer is 3. Next question. Let's solve the next question. This one is part per million. We will use part per million. Let's read the question. This is Regents question, Chemistry 2018. 240 gram sample of an aqueous solution. So that is the mass of a solution. It contains 0.012 gram of ammonia. That is the mass of solute. What is the concentration of ammonia in the solution expressed as part per million? So you will go to table, find the part per million formula, mass of solute divided by mass of solution times 1 million. Mass of solute. So mass of solute is given right here, 0.012 gram divided by mass of solution. Solution is 2400 gram times 1 million is 5 ppm, which is A. Next question, again from same year, they ask another one. This time, what is the total mass of solute? Solute mass is asked now. In 1000 grams of a solution having a concentration of 5 parts per million. Now the concentration is given, mass of solution is given, they are asking mass of solute. So we need to reorganize the formula. Let's find the formula again. Our formula is mass of solute divided by mass of solution times 1 million. Mass of solute, question mark, we don't know. It's given 1000 gram times 1 million equals 5 ppm, and if you do the math, you will find the mass. I'm gonna stop here. We will continue next time.